Welcome to the channel. Here we are having a question like this. A rope of length L and mass M is being pulled on a rough horizontal floor by a constant force F, which is also horizontal, and F is equals mg. The force is acting at one end of the rope in the same direction as the length of the rope. The coefficient of kinetic friction between rope and the floor is off. Then the tension at the midpoint of the rope is. If the question is made clear, then you have to understand such a situation like this. I call a rope in this way. Here is the rope. I simply assume. Okay, let's think this is the rope, and which is placed over a horizontal surface, and which is applied with a horizontal force F is equals mg. Now the mass of this rope itself is m, what he says in the question, right? So mass of the rope itself is m and length of the rope is L. Now let me check whether the rope moves with this force or not. For that we have to think about the friction. So friction will act in opposite direction to the applied force, this. Okay, so this is friction. If I think about the static friction, okay, so static friction, Fs is equals, how actually we write? We write mu s into mg. Okay, so in most of the situations, what actually we know about this mu s. So if mu s is less than 1, then definitely this whole thing Fs is less than mg, and this mg is force, right? So that is nothing but Fs is less than mg. So mg stands for the force, applied force F. If this is true, right? This is true. This force is more and this friction is less, right? So from this convention, what we get? Applied force is more. Applied force is more than the static friction. So this means the body, right? A rope moves horizontally in the direction of in the direction of F, applied force. So further, I have to find the tension at the midpoint of the rope. Okay, the tension at the midpoint means, say this is the midpoint, what we may think about. So at that point, what should be the tension? So in this circumstance, I find the net force on the body. So net force on the rope, net force on the rope, say it is some F dash, which is equals, which is F minus Fk. Okay, so what is Fk? So Fk is a kinetic friction. Okay, so this should be kinetic friction. This comes during when the rope moves horizontally in the direction of the applied force. So F dash is equal to, F is what actually F? F is mg, which is applied force, minus this is a mu k into mg. Since I know detail about mu k, I can simply put F dash is equals mg minus this is half mg. So definitely F dash is equals half mg. So this much I got about F dash. And now what the situation is, if we call this is the rope, right? This is the rope, and now the net force is acting in this direction. This is F dash. So F dash must be is equals mass of the rope into the acceleration. So which implies A is equals F dash divided by M, which is equals what I can put? I can simply put half mg divided by M. So which means A is equals g divided by 2. This will be the acceleration of this rope. Okay. So now there comes the question, the tension at midpoint. Okay. So this is the midpoint as we already marked. So this is the midpoint. Now what I have to do is I simply split this rope into two parts. So one is this part. Okay. Another one is this part. Like this, I simply call two boxes connected with a massless rope, and here I can find the tension. This is the tension at the midpoint. Okay, so this is tension at midpoint. Tension at midpoint. Right. So the force is acting here, which is F dash. Right. So both the boxes are having the same acceleration because they are connected with a rope in between. Right. So how much should be the mass of first box? It is m divided by 2. And how much is this much? This is also m divided by 2, because both masses are same, since it is said it is the midpoint. The tension what we are finding at the midpoint, right? So now tension must be is equals. Therefore, tension must be is equals. It is m by 2 into a. So mass into the acceleration. So which is equals m divided by 2 into what I must put here. It is a g divided by 2, right? So this is nothing but mg divided by 4. This will be the tension which is acting at the midpoint of this rope, right? So mg divided by 4. Now search that answer which is correctly said in option 1. So this becomes the answer.